Ashish, you want to say something? So what we were seeing in the previous turn, it was file system, and we were here at the previous turn, mounting the file system. So there can be many file systems in your the way you have formatted your hard disk and how your operating system uses that, and uh, and if you want to attach another file system, maybe your pen drive or any other secondary storage thing, you want to attach another file system, then you need to mount it. It is just similar to the way you first open the file and then you can use it. So let let us see that how many file systems can be there in a system. Uh, there are certain commands you can use. Uh, Say if I use mount command, so you're not able to see it. Just let me format it a bit. You can see these are the various file systems uh, in my Linux box. Fine. You can use uh, find MNT is also a command, I think. Let us check. Yeah. So this find MNT is also a command which gives you the file system, number of file systems in a tree kind of structure. You can see started from root, then sys, then these different file system, then our proc file system, our dev. Can you guys give me 2 minutes because I think my machine is misbehaving a bit. I'm switching to a different machine, and that would be easier for you because I need to use Linux commands also, and this particular machine is misbehaving. So just 2 minutes I'll take, and I'm switching to a different system. So, it is little bit misbehaving. You people keep connected. You are not required to do any change. Yeah, Bhavya, am I audible?
Yes, sir.
Okay. And you can see the slides also.
No, not the slides. They haven't loaded.
Slides are
Now
not
we can.
visible?
Yeah, now we can see.
Okay. So all set. So what I was telling that we were here in the previous turn, and we have seen many aspects of files and file system. And today we'll start from here. Actually, this is going to be a long module. A lot many things are going to be covered in this, and it is just like the most important part of your operating system, because this is the module which you encounter more often than not while interacting with any operating system. So I was telling you about the mounting any file system. So when a system boots up, a root file system is always mounted by operating system, and rest other file systems uh, either OS mounts, or suppose you want to mount it to to a specific place in a directory structure, you can do that thing. Fine. So you need to find an empty directory in the directory structure, and then using a mount command, you can mount a particular file system to that empty directory, and then that file system becomes a part of your directory tree or directory structure. So there are various commands available to use to know how many file systems are there, and how to do the things, and that's what I wanted to tell you. uh, so the easiest one is mount. Just write mount, and you'll be able to get the file systems, which are the file systems which are there. Fine. You can use df also to know the file systems. These are the file systems which are there. I was telling you about find mnt. Find mnt can also give you file systems in a tree format. That is a root file system, then sys, another child is proc, another is dev, run, and then so many. Fine. If you want to see it in a list form, you can run mnt uh, with list. Find mnt minus l. So you can get a list of the file systems. Fine. Now, if I want to show you the how the things are getting done, Linux already gives you an empty directory. Fine. Let me see whether you can have that or not. So let us do the ls. You can see here there is a mnt directory. Fine, which is where you generally, if you want to attach any file system, so in a directory structure there is a mnt directory which is already there. Suppose I go to mnt, fine, and ls, will find nothing. It's an empty directory which is there in your system to attach any file system. Fine. Now, later on, we'll study the network file system also.
वही लैपटॉप साफ करवाना है, अब दिवाली पे ही करवाऊंगा। कैसे साफ होगा? अपने आप ही बंद हो जा रहा है, साफ होगा तभी सही होगा। बटलर को
Brijnandan,
का
Brijnandan Gond, Mr. Brijnandan Gond, are you there?
पैसा लगेगा क्यों? गारंटी के डालल बा, ऐसा लगेगा। गारंटी गैस का 1 ही साल का रहा होगा। कौन साल हो गए? कब लिया आया था? दिवाली वाली पे लिया आया था 18 में।
Bhavya,
Yes, sir.
what do you say? Brijnandan Gond was attending class?
I don't know, sir. I'm not sure. I don't want to comment on those things, sir.
Athar?
Yes, sir.
Come clear, yaar. We are grown-ups. Was he attending class?
Sir, I think he heard you but ignored you or something like that. I'm not sure. Even
But he
I'm
was
not.
very attentive to the class, no?
Uh, no comments.
Good, good. I like that. Good, I like that. You people are good friend of each other. Good. I seriously like that. Anyways, so I've shown you that you can see the file system, and right now I'm not having a Linux version which doesn't, directly mount your things. Otherwise, I would have shown you earlier. We used to specifically mount any pen drive or floppy drive or all those things to make it part of the file system. Now, there is a question from my side, which is very pertinent, and because nobody else responds, that's why I keep on asking these 2-3 guys only. So let me go to Jatin Agrawal. Jatin is there? Rachit Awasthi is there?
Yes, sir.
You do have Linux on your machine?
Sir, currently I am on Windows, but yeah, I have dual booted my system.
You have a dual booted machine. Okay, can you tell me which file system Linux uses?
Sir, I remembered when I installed it, it was showing NTFS.
NTFS in Linux? Okay, anybody else wants to comment on this?
So when I used the pen drive through which I dual booted my system, the pen drive was showing the NTFS system, which I had to install the
So
multiple.
you must have made a drive bootable, no?
Yes, sir.
And
Using
bootable drive is no. So you have to go back to it again. Okay. So let
okay.
me ask somebody else. Shresh Tandon is there?
Yes, sir.
You have Linux on your machine?
Yes, sir. I use it on VirtualBox.
You use it on VirtualBox. Which file system Linux uses?
I don't know, sir.
You don't know. Okay. Niharika Singh, are you there?
Yes, sir.
Yeah. Which file system Linux uses?
Sir, I don't know.
Don't know. Now, Athar, you tell which file system?
Excuse me. Yes, sir. Sir, I think it's Linux file system itself. Means it's called Linux file system.
No, it is not called Linux file system.
Okay, sir. Then I'm not sure.
Bhavya?
Sir, ext4. For the newer
it
ones.
started with extended 2, extended
Yeah, 1,
extended
2,
file
3.
system,
Yeah, it
1, 2,
started
3, and
from there.
nowadays it is extended 4.
Yes.
Now
sir.
my question
And
is there, Bhavya. I just want to ask, what is a file system? Because I'm teaching this particular thing. I just want to understand from you guys that what actually you people have comprehended. What is a file system?
Sir, it just is a way of storing files at the drive level. I mean, it stores the tree structures, like the B plus tree, how they're organized and where it points.
But this
That's what
geometry is very different.
What, sir?
This stores the things. I'll tell you today itself. Disk stores the things in form of track sector and cylinders.
Yes, sir. But sir, it's very difficult to, do things at the disk level. You need one more abstraction layers. Like we have several abstraction layer in the networking model. So we have several abstraction layer even at the disk model to simplify
So
things.
it would be correct to say then, you are right. It would be correct to say then a file system is a logical thing only.
Yeah, it's just an abstraction layer.
It's just an abstraction. Fine. So when you format your disk, what actually you are trying to do?
You delete the thing that contains the
You
file in.
format your disk using certain file system.
Yeah.
When you are formatting, actually, there are two types of formatting: low level and high level. So I'll come back to that. So when you are doing high level formatting, low level formatting is something else. When you are doing high level formatting, actually you are trying to make a file system on that disk.
Yes, sir.
So file system is a data structure. The way you have your data structures like linked list and trees and B plus trees and arrays and all. So file system is a kind of data structure which is utilized. You require a data structure to search the data, to manage the data, fine, to traverse the data. Similarly, file system is a data structure which is actually superimposed over your hard disk. With hard disk data is having another structure, which you have rightly said that it would be very difficult to search for the data or to manage data if we go and keep on asking hard disk controller for everything to be done. So we require some abstract data structure using which it is very good. It is very easy to search a folder, subfolder, subfolder. Fine. It is very easy to search a directory structure. So directory structure is just nothing but file system, or file system is nothing but a logical manifestation of your hard disk.
Yes,
Now
sir.
my question is, as you have rightly said, Bhavya, that when we use Linux, we format our hard disk or the partition of the hard disk, which is going to be used by operating system, a partition of the hard disk, we format it using ext4 or ext3 in older Linux. So when you connect your flash drive, in which file format, file system it is formatted? Any pen
Sir,
drive
that
or...
it depends, sir. I have formatted them in NTFS, some in FAT32, some in other systems.
So generally they come in FAT32 or FAT64.
No, sir, FAT64 is in there.
FAT64 isn't there. So now understand the issues. Your pen drive is in different file system. The data structure which is getting utilized to search data, to manage data in your pen drive, that is FAT. That's a different file system. And you are trying to attach that file system to Linux file system, which is ext4.
Yes,
We'll
sir.
see it. We'll see it today. The organization of FAT is known as file allocation table. An organization of ext4 is entirely different. So how these things are managed? So there are two things you need to be very sure about. We can have many file system, all are following extended 4, ext4. That's a different story. We can have many file systems in our machine, which all are following, like device SDA1 is FAT extended 4, device SDA2 is extended 4, fine. So that's another story, that many file system of same type. And then another twist comes when many file systems are different type. So modern operating system actually supports many types of file system. And that is what we need to understand very carefully, that how we provide support of all the file system. You just want to make your system plug and play. Wherever you insert your drive, whether the original file system is whatever, your files should be accessed. That is what is the design goal. Ayush, Akash want to say something? You have unmuted. Ayush, Akash. Okay, so let's move a bit further. The OS maintains an in-memory mount table and list all the file system currently mounted. And we can use those commands which I have told. This first file system that holds the kernel executable mounted at the root of the directory during boot time. This is done by operating system. Kernel executable can be read off the root file system during the boot process by the bootloader. So by default, the root file system, the kernel executable /vm/lineage is attached to a root of the default file system, and then bootloader can read the kernel executable from there. Important aspect, disk buffer cache. So for efficiency, operating system caches disk blocks in memory. And these cached disk block correspond to both file data and metadata. Means both inode and both data blocks. Improves performance by reducing the number of accesses to a relatively slower secondary storage. Actually, hard disk, that too a magnetic hard disk, is the slowest device, slowest IO device in your machine. So that's why you cache certain inode block and data block in main memory, and that is known as disk buffer cache. When operating system uses disk buffer cache, actually the request for the files to read the block or to write into the block not directed towards the disk. They are first directed to the buffer cache. If the request cannot be satisfied within the cache, now then the device driver will come into picture and it will request this controller to fetch the block from the hard disk and store it in disk buffer cache. So all the file read write request actually goes to the disk buffer cache instead of going to the hard disk directly. If that particular cache is not having that requested block, then only disk controller with the help of device driver bring back the disk block into the disk buffer cache. There's another interesting aspect. You might have utilized this, but haven't used that. Usually, there are certain space in the hard disk which we declare as a swap space. So swap space is a space later on in memory management. We'll see that you keep on swapping in and swapping out certain pages or certain blocks of data from main memory to hard disk. Now, if you don't have these raw partitions means these are not going to be accessible through a file system. Otherwise, if there is file system on the disk, for every access you need to go through the file system. That data is structured, and you are not allowed to access any block on the disk directly. Sometimes we require these things. We don't want to go through the file system, and we want to get the data as quickly as possible. So initially, when nowadays we don't declare swap space actually, because the main memory is very cheap and we have a lot of main memory. In our days, we used to have double of the main memory swap space declared in the hard disk, which was declared as raw partitions. Means to access the swap space, you are not required to go through the organizational structure of the file system. You can just directly fetch the data block from the raw partitions. In another cases, there are underutilization also in databases and all. Suppose you want to bypass some of the functionalities of file system. You don't want to utilize your database application, don't want to utilize this buffer cache and something like that, and want to have its own more intelligent and more sophisticated caching functionality. In that case, again, you require your disk to be having partition which are not following any file system. Wait a bit, I had to take this call. वर्मा क्लास में है अभी. Fine. Layers of abstraction, as Bhavi was also suggesting, that there are various layers of abstraction, and from that discussion actually this thing comes up. User or even OS accesses files via file systems through a system call interface. So we have seen in the previous an open and closed system call, and when we use open system call, what happens? We get a file descriptor, we get an entry in a system-wide file table and a per process file table, open file table, and these system call interfaces you have seen in your C programming. There are library functions available, fopen, fclose, which in turn use system calls open and close, which in turn use sysopen, sysclose at the lower level, and then your work is done. So you can access your file system via C program using fopen, fclose, via using system call library open and close, which in turn uses actual system call sys_open and sys_close. So this is one abstraction. Now, if you talk about modern operating system, they support several file systems: ext2, ext3, ext4, ZFS, AWS. There's so many file systems, or network file system, or network attached storage. Fine. Or storage area network. There are so many things which are supported by modern operating systems. And we'll see later on, and you'll find this out, that each file system stores and accesses its file differently. The way the blocks are organized, the way the interconnection between blocks are there, these all are different. Means the implementation of the system calls, when you want to open a file, so you just say open, how that file is going to be searched in the hard disk, how that file block are going to be copied back into disk buffer cache, how those file blocks are going to be actually in memory and getting opened, that is going to be different across different file systems. Each file system will be having its own methodology. Now, what you don't want to know the details, and you don't want to have 20 different versions of open file system call. Otherwise, what would have happened? That open ext2, open ext3, open ext4. These are all different system calls. If you want to open a file from ext4 file system, use open ext4. You don't want to have that thing. To avoid this, nowadays operating system like Linux provide another layer of abstraction that is known as virtual file system. That is known as virtual file system. Fine, please understand it carefully. Underlying, there may be different file systems using different methodology, using different techniques to access the data, to store the data, to create the file, to read the file. Those methodology may be different. That depends upon the implementation of different file systems. But everything else is going to be hidden, and then you are again going to get a clear system call interface using virtual file system. So another abstraction is provided by Linux known as VFS. What is VFS? So a file system interface, which is nothing but your system call interface. See the mouse pointer, which actually gives command to VFS interface. And this VFS interface actually works as a translator. So when you say open, VFS will provide you that file in open condition. How this file is going to be opened in hard disk, in flash drive, or in network file system, that is all different implementation. So VFS will give command open this file. That file will be opened using its own architecture, and the opened file will be written back to VFS, which in turn written back to the file system interface. So what VFS is a way to abstract out the implementation details of file system. Common skeleton for implementing a system call across different file systems. Okay. Now, a related thing. How many of you understand the concept of abstract data type? You can raise hand if you know. The concept of abstract data type, ADT. Yeah, Kunal Jindal.
Yes, sir.
Do you understand what abstract data type is?
Sir, basically those data types जिसमें हम we hide the major details of implementation and just show the necessary details to the user.
You are telling the meaning of abstract word. Can you give the example of abstract data type?
So like um, uh, uh, maybe a linked list.
Linked list is abstract data type.
Yes, sir. In a list, or we can also say a queue or something, because like in queue we have a push or a pop operation, but we don't generally go into the implementation that how they are implemented.
So queue is abstract data type. Stack is abstract data type.
Yes, I think so.
Okay. Anybody else? Pranay Verma.
Yes, sir.
Yeah, Pranay.
Sir, mainly abstract data types are those data types which have a defined structure but can be used in many ways, like stack queue.
Okay. Ritvik Josh.
Yes, sir.
Yeah.
Basically, it's just a mathematical model, sir, for data types.
Okay. Sonu Sharma.
Yes, sir.
What are abstract data types? I think we have lost Sonu. You can give answer in chat, Sonu. Yeah, Atharv.
Yes, sir. Sir, that's. I think that like we have a mathematical model, we implement it, but we do not tell the user what exactly is happening inside that model. We just tell him what he will get by implementing some methods from that model.
Why you are saying mathematical model?
Means suppose we consider the example of vectors in CPP. There are some methods like cbegin or end. So we do not know the internal functionality of those methods, but we understand that we will get the pointer to the front and to the pointer to the end from these methods. How we are getting it, we are not sure.
What about tree?
So tree, I think also is abstract because we are
Abstract
implementing
or
it.
user defined
Uh,
or derived?
User derived actually, because we are deriving it similar to linked list. Means we are constructing it similar to linked list.
Okay, Bhav, you want to say something?
Sir, I mean, like queue is an abstract type in the we don't know the internal work. It may be implemented as a linked list or as an array or even a more complex structure. For example, a list of arrays like the DEX in CPP. So we don't need to know any of that. We just need to know the API and how to communicate with the data structure, and it will
You need
work
to know
in
the
the similar
methods.
fashion. Yeah, we need to know the method or the API.
And the function which you can apply on that.
Yes, sir.
So I can have my own data type, which I can declare as a list. Suppose I can have a list data type. So how that list is implemented, whether the sorting is happening in insertion sort or bubble sort or quick sort, fine. You get a sort method, okay?
Yes, sir.
So you get a traverse method, you get a sort method, you get a. So I think I get one chat message also. Different functions can be abstract data type. No, Sonu. I think you have to look at the answers what Atharv and Bhav have given. So what is abstract data type? That because there are some basic data types like integer, float, and all that. At a different reference level, these integer and float are also abstract, because how that integer is actually implemented in hardware, how that float is actually implemented in the hardware is again hide it from you. So at the programmer level, API level, integer, float, and all that long integer, short integer, these all are basic data type because you know what is happening over there. So there is abstraction and happening everywhere, and the similar thing is happening in file systems also, in virtual file system also. So what VFS provides you a file system, which is nowhere, which is a virtual file system. So what is there in the file system? In file system, there would be inode, there would be how to create a file, how to open a file, how to delete a file, how to truncate a file. All those operations are going to be there. Fine. Ma'am, class में अभी. All those things are going to be there. But how those things are implemented internally, those are abstracted from you. Fine. So file system type 1 can implement in a different manner, file type 2 can implement, type 3 can implement in different manner, but you get a clear-cut universal interface, whatever is the requirement of any file system. That's what is mentioned here in the slide, that VFS defines a set of abstract objects, files, directories, inodes, superblocks, boot blocks, and operations can be performed on this object. Though the operation which can be performed on these objects are also defined. To create a file, to create a directory, to allocate an inode, to read the superblock, All those things are also defined. But the implementation may be different as you change the type of the file system. And those things are actually hidden or abstracted from the application programmer or operating system. Fine. So this is how VFS gets implemented. Another important aspect is VFS abstraction just not integrates the regular disk-based file system, but it can integrate the pipes, sockets, special file systems like ProcFS. ProcFS will come back later on. It's a proc file system, and the network file system like NFS. Fine. So it can just give a clear-cut universal interface. Whatever you can do with the actual file system, you can do with the virtual file system, which is not there, which is getting implemented differently in different file system. Now you can have your own user space file system also. It's not like that the VFS is going to provide you the kernel file system or kernel file system module only. You can have your own user space file system where the entity implementing the VFS function is not kernel code but a user space process. So you can have your namespace, and that namespace, I'll tell you later about namespaces. A user can have its own version of file system using VFS. The way a user wants to arrange the files in its own shell or own space, that can be done by a user. You can take one example. Suppose a file name is received via open system call. So you just receive a file name, which can be a relative file name or a absolute file name. So kernel code of VFS starts walking down the path of the file name /this/this/this/this/this. At each stage of a walk, VFS performs lookup on a directory object to locate the inode of the next directory or file in the path name. So you go to the folder, you see the list of inode, go to the another subfolder, go to the another subfolder, and at every step you keep on looking at the different inodes. Now this lookup implementation is specific to each file system. It depends on how file entries are stored in the directory object. FAT may store in a different manner, NTFS may store in a different manner, extended 2 can store in a different manner, extended 4 can implement in a different manner. VFS is not concerned with this complexity. It simply invokes a lookup function from the pointer given to it. If the file to be opened is not found, a new file is created, an inode is allocated for it, and a pointer to it is inserted into a directory object. Once an inode corresponding to a file name is identified or a new one is created, VFS installs a pointer to it in the open file table and returns the file descriptor. How all these things are getting implemented, that is specific to the file system. Now we can revisit the layers of abstraction in file system. OS exposes the system call interface to user programs and libraries. The system call interface is implemented by VFS, defines an interface consisting of set of generic objects and functions, translate the system calls into functions calls on these generic objects, and finally actual system calls implement these functions called by VFS to issue, for example, calls to read write blocks from the hard disk. So user system call देगा, system call implement होगी VFS के objects पे, VFS इन system call को implement करने के लिए function call करेगा, और वो function call different objects, different file systems के लिए different होंगे. तो इन functions call का implementation different file system के लिए different होगा. This is how everything is abstracted from the user's perspective. The calls then pass through a buffer cache, which first try to serve the disk read-write request from the cache memory, passes them over to actual disk hardware, only in the case of cache miss, When blocks must be fetched from the disk, then device driver come into picture, uses disk controller to fetch the content of a specific block number from the disk hardware into the main memory. So this is the whole path from top layer to the lower layer of device driver and disk controller. So each layer provides an abstraction to the layer above it, hides the implementation detail of the lower layers. Each layer also depends on a service provided by the lower layer. System call VFS से मांगेगा service, VFS नीचे actual file system से service मांगेगा. Actual file system पहले डिस्क बफर कैश में ढूंढेगा, वहां नहीं मिलेगा तो वो डिस्क डिवाइस ड्राइवर के पास जाएगा, डिवाइस ड्राइवर फिर डिस्क कंट्रोलर के पास जाएगा, फिर डिस्क पे रिक्वेस्ट जाएगा, एंड दिस इज हाउ the whole thing is. And you can take file system as a classic case study how a modular layer design can greatly simplify a very complex subsystem such as file system of operating system. Fine. So I think I have given a brief idea of file system, that what is a file system, how we go about that. Is there any question you can ask? Think over it. I'm giving you a break of 5 minutes. 5 minutes break and then we can again start. Okay. Okay, we can come back. Am I audible?
Yes, sir.
Okay. So now the important aspect, allocation methods, how the blocks get allocated on disk. And I'll tell you this block again is a logical thing. We'll be coming back to this. So there can be three types of allocations: contiguous allocation, linked allocation, and indexed allocation. Fine. Now this is contiguous allocation. See here, there is a directory. Directory is having a list of files, and file is telling you what is the starting block number and what is the length. So like file count starts from 0 and length is 2, and that's why the count is having allocated on 0 and 1. Mail is starting 19 and length is 6, so it will start from 19 and end at 24 rather. So each file is allocated contiguous block on the disk, where directory entry keeps the start and the length. So where to allocate? You get the first block where the file can get first block of contiguous, first group of contiguous blocks where the file can be allocated, or you will search for the best one where it can be compactly allocated. The advantages: it is easy and simple, may lead to external fragmentation, that you have a certain block and you have allocated the file, and there are so many things which are so many blocks which are remaining, but no other file can be allocated in that. User need to specify the maximum file size at the creation. So when you open a file, at that time you have to give the maximum file size. That okay, these many blocks are going to be. This may lead to internal fragmentation. A file may request a much larger space and not use it, but it has allocated that space. It's a simple allocation method. No file system, no actual file system uses this. It's just a demonstration that okay, this maybe some smaller file system might be using that, the contiguous allocation, but it's not implemented in general. Second is a linked allocation. So directory entry just stores the start and end blocks, and every block stores the pointer to the next block. Suppose there is a file Jeep which starts at 9. So 9 will store a pointer to the next block, 17. 1, this will store a pointer to the next block, and so on. And then last block will be storing a pointer. So say here, you go to block number starting fine at 9 block. 9 is storing 16, you go to 16. 16 is storing 1, you go to 1. 1 stores 10, you go to 10th block. It stores 25, you go to 25. And in 25, there is end of file, -1. It means the file is ending here. It solves external fragmentation problem because you are going to get those many blocks which are needed. Disadvantages: not suited for direct access file. All pointers need to be accessed. Pointer needs to be stored. That is another overhead. Every block has to store the next pointer. Overheads can be reduced by using clusters. You can group certain blocks, and one pointer can actually address a group of blocks. Reliability: if a pointer is damaged, rest of file is lost. If one pointer is broken, the whole file is going to be lost. Or a bug in OS may result in a wrong pointer being picked up. So this is how the linked allocation work. Directory entry has the start and end, and rest other blocks are storing link to the another pointers to the data block. Fine. Linked allocation. Actually, FAT uses linked allocation. You can say this is how FAT is there. So there are 3 files: red color, blue color, and green color. So red color file move starts at 5. So let's go to the block number 5. 1, 2, 3, 4. Which is the 5th block number? It starts at 5. So this is 1, 2, 3, 4, 5. It starts at here. Fine. 0, 1, 2, 3, 4, 5. It starts at 5 here. Fine. And then if you go to 5, fine, it stores a pointer to 1. Go to 1, 0, 1, and then it stores a pointer to 12. You go to 12, and then from 12 it is end of file. So it starts at 5. Fine. 0, 1, 2, 3, 4, 5. It starts at 5. We go to the 5th block. It stores a pointer 12. We go to 12. It stores a pointer 1. We go to 1, and then end of file. Let us see for green one. Green starts at 14. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It starts at 14. 14th block stores a pointer to 18th. We go to 18th. 18th block stored a pointer to 28. We go to 28. And 28 stores a pointer to 15. We go to 15, and then 15 there is an end of file. So this particular linked allocation, the FAT file system, was invented by Mark McDonald and Bill Gates. FAT is a file allocation table that contains one entry for each block and is indexed by block number. File represented by linking pointers in FAT. FAT table. This FAT table is generally cached to look at the block numbers quickly. Advantages: solve direct access problem of linked allocation. Now you can directly access any file. Easy to grow files because you are not required to declare the file size at the beginning. Greater reliability. A bad block implies only one block is corrupted. Disadvantage: the volume size, the partition size, the volume size is going to be determined by the FAT size. That how many entries a FAT file allocation table can accommodate, accordingly the volume size is going to be determined. And finally, the indexed allocation. Advantages: supports direct access, no external fragmentation, easy to grow file. So directory structure would be having just a pointer to the index block, address of an index block. And that index block, 19 in this case, is going to hold the pointers to the data block. So you go to the index block, then 9, 16, 1, 10, 25. So you go to 9, 10, 1, 16, 25. Fine. So this is how index file system work. Index allocation works. Use disk blocks at index block that don't hold file data but hold pointers to the disk block that hold file data. How large should the index block be? First, files typically 1 or 2 blocks long. Index block will therefore only have 1 or 2 entries. If you have a large index block, huge wastage. A small index block will limit the size of the file. Need an additional mechanism to deal with the large files. The file is large, you have to have many entries, many block number entries in index block. Disadvantage: sequential access may be slow. We can also use clusters here also. Group of blocks can be given one index entry. Sequential access, where one block after another you want to traverse, you have to again come back to index block for the next block. We can have multi-level index also. So the first index block will be telling you the outer index, then second level, then last blocks. And this is how, in a multi-level index format, our ext2, ext3, and xv6 is implemented. So this is at the left. This is our inode. Inode is having entries for some direct data block, index for direct data block, which are good for small files. Then single indirect entry is giving you another index block, which is pointing to data block. Double indirect entry is giving a pointer to index block, which is again given a pointer to another index block, which are, and then triple indirect also. And these double indirect and triple indirect are good for very large files. So in this way, Linux work fine. Linux ext2, ext3, ext4, and xv6 work. So there is a inode. Inode has pointer to some direct data blocks. Single indirect, where pointer to an index block, then data block. Double indirect, pointer to index block, then pointer to another index blocks, and then data blocks, and so on and so forth. So these are the allocation methods I told you. Fine, that how a file is actually going to be allocated on hard disk. What would be the, and now you can see the utility of VFS. So if VFS has to open a file, and suppose this hard disk is having FAT, this is having ext3. So when a open command goes, VFS open command, when VFS fires a open function here, that is implemented in a linked allocation method. So where you go to block by block, one after another, to get the file. When you go to ext3, VFS gives you a plain interface of opening file or writing into a file. Then you need to go by index allocation. So the different file system have different implementation and allocation methods, and VFS gives you a facility to hide everything, what is going behind the scene. Now the magnetic disk. Fine. So this is left hand side is a structure of a magnetic disk, where there are so many platters and read-write head on each platter, and group of platter actually gives you a cylinder. Fine. So track, cylinder, and this is sector within that cylinder. So you can see the tracks. These are tracks, and on track there is one sector. So these are different co-circular things, and then there are tracks on these. There are sectors on these tracks. For example, you might have seen old gramophones where you have these kind of records, where a head is, you can put the head anywhere to listen to a song. Fine. So there is a spindle around which the hard disk moves with a certain RPM, and this head moves in a stationary direction from outer track to inner track. And because hard disk is moving with rotationary, so every sector, suppose a head is still at this point, so every sector, because it is moving also, rotating also, every sector can be inside this head for some amount of time. And because its head is moving in this stationary direction, you can move from one track to another track. This is known as the structure of the hard disk or magnetic disk. How SSD works, this is your reading assignment. So when we are dealing with magnetic disk, there are certain things which we need to be careful about. Seek time. Time it takes the head assembly to travel to the desired track. Seek time may vary depending on the current head location. Abhi kahan pe head? Average seek time generally considered typically 4 millisecond for high-end servers to 15 millisecond in external drives. Look how slow the magnetic drive is. 4 millisecond, where computer thinks in nanosecond, hard disk is thinking in seek time of hard disk is 4 millisecond. Rotational latency. Delay waiting for rotation of disk to bring the required disk sector under the head. Rotation depends on the speed of the spindle motor, how fast, and that's why when you purchase a hard disk, you get the RPM of that hard disk, rotation per minute. Depends on the speed of the spindle motor. There are two types of rotation, CLV and CAV. We'll be coming to that. So there are three times which are important seek time. Head को उस track तक और उस sector तक ले जाने के लिए. Rotational, उस track तक ले जाने के लिए head move करता है. उस सेक्टर को हेड के नीचे लाने के लिए रोटेशन लेटेंसी है. और फाइनली टाइम टू गेट डेटा ऑफ द डिस्क, दैट इज डेटा रेट. So you can see the structure of the hard disk. Outer sector can typically store more data because they are bigger. Inner sectors can store less amount of data. क्योंकि इनर सेक्टर में ब्लॉक कम होंगे, ब्लॉक उतने ही होंगे, ब्लॉक का साइज कम होगा. और अदर वे अराउंड यू कैन आल्सो से दैट ब्लॉक कम होंगे अगर ब्लॉक का साइज इक्वल रखना है तो. CLV is constant linear velocity. Spindle speed is dynamic, varies depending on the position of the head. अगर आउटर वाले पे है हेड तो थोड़ा जल्दी चलेगा, और अगर इनर पे है तो थोड़ा धीमे चलेगा इस मोटर, because you want to give constant linear velocity to maintain constant read or write speeds. This is used in your audio CDs. गाना सुनने के लिए constant data rate चाहिए, fine, and that's why this is used in your audio CDs. Constant angular velocity. Spindle velocity is always constant, used in hard disk, easy to engineer. Allow high read rate because there are no momentum issues. बीच में धीमे तेज नहीं हो रहा है मोटर. So this motor is rotating with the same velocity, constant angular velocity. High spindle velocity is always constant. This is generally used in the hard disk. Disk addressing. Now this is important. Bhav and Atharv, you can see here another level of abstraction. In older scheme, we used to have CHS, cylinder head sector tuple. कौन सा cylinder है, उसका sector उसका head means track कौन सा है और उसका sector कौन सा है track. Well suited for this, but not for any other medium. So we required an abstraction. So we started giving logical block addressing. So hard disk ने भी अपना address structure छुपा लिया. Well, I'll give you an abstraction of one-dimensional array of logical blocks. So जो block पीछे अपन बात कर रहे थे, that is not an actual hard disk block, that is a logical block. Actual hard disk block, again the logical block address need to be translated into actual hard disk address by your hard disk controller. Logical block is the smallest unit of transfer, typically of size 512 bytes. But can be changed by low-level formatting. Please don't try this particular thing at home, because low-level formatting can be done by Linux, where you can change the size of the logical block and the geometry of the hard disk and all those things. This is known as low-level formatting, but you may end up, your hard disk drive may be unusable after that. Addressing with 48 bits. How to map a logical MAC address to CHS or vice versa. So LBA is equal to C into HBC plus H into SPT plus S minus 1, where C equal to your cylinder number, H equal to your track number, S equal to your sector number, HPC is heads per cylinder, fine, tracks per cylinder, and SPT means sectors per track. Using this, we can convert a logical block address into a actual hard disk address. Now regarding disk, one more important thing, that is disk scheduling. The objective of disk scheduling algorithm is to minimize access time, and for that you need to minimize seek time and rotational latency, and then you need to maximize the bandwidth, byte transfer per total time taken. Access time and bandwidth can be managed by order in which disk IO requests are serviced. अभी इधर ये भी problem है कि in what order disk IO requests are coming, in what order those allocation methods are accessing the blocks, fine, whether it's an index allocation or a linked allocation, depending upon that, head will move differently, fine. The goal is to reduce seek time by minimizing the head movement, fine. Final goal is to minimize the head movement. There are several algorithms which exist. Suppose there is a request queue from 0 to 199 block number are the maximum. This hard disk is starting from 0 and going to the 199 block. And the request is 98 blocks, then 183, then 37, then 122, then 14, 124, 65, and 67. These are the requests of blocks coming from the application. And currently the head pointer is at 53. So 53 block पे है head pointer और इतने blocks को अपन को request मानना है. So let's see the first of all FCFS. जो पहले आ रहा है पहले उसको request करेंगे. So 53 पे थे, 98 पे चले गए. Then we moved back to 1833. And again we came back to 37, then 122, then 14, then 124, then 65 and 67. Now if you see the total head movement, it is 640 cylinders. Total head movement is 640 cylinders. Fine. Another algorithm can be SSTF, shortest seek time first. जहां पे सबसे कम seek time आ रहा हो from the current head position, उधर पे जाएंगे. So we were at 53. 53 से सबसे कम कहाँ movement होगा? 65. 65 से सबसे कम कहाँ होगा? 67. From 67 we can move to 37. From 37 we can move to 14. From 14 we can 98, 122, 124 and 183. So this is shortest seek time first. The total head movement is of 236 cylinder. So this is the general algorithm which is actually general group of algorithms which I'm going to tell you next are generally implemented. Disk arm starts at one end of the disk, moves toward the another end, और रास्ते में जितना भी रिक्वेस्ट होता है सबको सेटिस्फाई करता है. 53 से शुरू हुआ 0 तक पहुंचा, रास्ते में जो मिला सबको सेटिस्फाई किया, फिर 0 से शुरू हुआ और आखिर तक पहुंच गया. Total head movement is here is of 208 cylinders in this example, obviously. There's another version which is C-scan. So it starts from 53, go back to the last end, then again the head is abruptly picked from last end to the first end and again go into one direction. So it will service the request in one direction only, come back to 0, again service the request. So it treats cylinders as a circular list that wraps around from last cylinder to first one. एक तरफ से last cylinder तक गए, फिर first one से शुरू किए, फिर आखिर तक गए. C-scan. There's a little bit difference between C-scan and C-look. Last तक नहीं जाएंगे, जहां तक last request रहेगा वहां तक जाएंगे. So instead of going to last 199, we can go to the last request in this direction and then can come back to the first request in the other direction. So it doesn't go to the end of the disk all the way down to the end of the disk. It will go to the last request, which is near to the end of the disk. See. So we'll stop here. We have seen so many things today. Fine. And I wish you just revise all these things. It is not that straightforward the way I have taught. When you think about these algorithm and this VFS and all these things, and start analyzing the things and start reading about the things, you'll be getting to know so many confusions, and you can always ask questions from me. Any questions at this point? Bhavya, any question?
No, sir, not right now.
Okay. Athar?
Sir, I just had a question about virtual file system.
Yeah.
If it is traveling through different kinds of file systems, it will need to address, means it will need to traverse through all kinds of systems, so it needs to have some kind of mechanism to traverse through each. So won't that become bulky?
Obviously, it is just like a module or a translator module. In simple term, you can understand that there is a translator who knows Chinese, Spanish, Mandarin, and French all. And that translator is right now in India. Fine. So at this end, it is taking the command in Hindi and then translating it in French, taking back the reply, again translating back into Hindi. Are you getting my point or not? So your question is very genuine. Obviously, if there is a VFS, fine, you need to have all the facility in the VFS to translate all type of file systems architecture. If it is not there, then you need to train your VFS for that. Fine. Suppose one fine day a new file system comes up, VFS will not be able to do anything. Got the point?
Yes, sir.
So you keep on updating your VFS if you want to support any new types of file system. I'll tell you, in our days, in 1998, there's a good story. If you want, I can share. In 1998, at that time, internet was like, if I want to send a mail, I would draft a mail on using Pine. Pine used to be a Unix facility at that time. So we used to, compose the mail on Pine. It was a textual, monochrome monitors, no multimedia, no mouse. So we need to use our keyboard, write the mail, and then press the send button. And then you can go and come back after having a cup of tea. And if your luck is good, your mail would be sent. So it's just like at that time, there used to be a magazine known as PC Quest. So in that magazine, I purchased it and from somewhere, and suddenly I saw that there is a CD attached as a free gift, and that CD was Red Hat Linux CD. And then there was a small article on that Red Hat Linux, that how to make your system dual boot and install this Red Hat Linux. So it took me around 20 days to make my system dual boot and install Linux in 1998, because there was no internet, no help was there. It was just hit and try. And then we learned, there are a group of four students. So at that time, computer was like a luxury. If you have a computer in your room, means you are a good big gun, fine. So I used to have a computer, and then I formatted my hard disk, done so many times, so many changes. There used to be Lilo loader at that time, Linux loader. And finally, I could do that. Then in 2000, in year 2000, December 2000, I was in IIT Kharagpur. And then suddenly we get to know about this VMware thing. I again tried it to make my machine and run a VM on that. Again, it took me a lot of time to install VMware and to run Linux as a virtual machine. So there were so many issues at that time, and the things you were asking, from that time 2000 to 2020, majority of the things have been solved. We could not mount Windows file system to Linux at that point of time. Even if we make an entry in our FS tab that okay, device CDA or CDC1 is Windows partition, and mount it at the boot time or mount it manually, we could not do it because Windows VFS was not, Linux VFS. First of all, it was not having a VFS. It was having a very small, you can say, a very miniature VFS at that time. So the VFS was not capable to understand non-Linux or non-Unix file system. So then we understood that we need to give a device driver to Linux to understand about the file system. So up till 2007, Linux was not able to understand, VFS of Linux was not able to understand NTFS, 2007. So I used to have Windows 2000 server in my machine, and that was running NTFS at that time. And then we need to install a driver of NTFS and make Linux capable to understand NTFS to mount the file system over there. Are you getting my point now?
Yes, sir.
So this is how you need to do. If your VFS is not capable to understand a certain file system, you have to make your VFS capable of doing that thing. Fine. And that's the beauty of abstraction, that you can actually change the lower layers. Upper layers would not be affected. The way you access any file would not change because VFS is giving you a universal interface. What you need to do, you need to just change the inner layers. Okay, Atharv, can we answer one thing? Is Java platform independent?
Yes, that's what it is advertising. We learned
is
that
platform.
it is system independent.
It is platform and system independent. Bhavya, what do you say?
Sir, not completely. Only
Okay.
the what do you say, simple arithmetic operations are, but file system operations are not independent. You have to have what do you say, I mean, you have to have separate functions for different file systems, and it's not completely independent.
Okay, let me define my question. Is JVM platform independent?
Sir, it's actually not possible to have it completely independent.
No. My question is not completely or incompletely. I'm saying Java virtual machine over which you run
Yeah,
run
I
your
know, I understand.
JDKs and Java. Is JVM platform independent?
I think so, not completely. I'm not sure.
Not entirely, actually. Not. So JVM for Linux you have to have a different JVM. For Windows you have to have different JVM.
Yes, sir.
So the similar thing, Atharv, if you pay attention.
Yes,
So
sir.
VFS is giving you similar thing like JVM. So when you go and install JVM for Android, JVM for Windows, JVM for Linux or Unix, these all are different. You have to install different thing from sun.java.com, and then they give you a kind of, not exactly, but kind of platform independent interface. What Bhav is saying is also right, that it's not completely independent. You need to have some drivers for certain other aspects. You got the point, Atharv, now?
Yes, sir.
Any other question from anybody? अच्छा, एक इम्पॉर्टेंट चीज बताना था आप लोग को। अभी 2-3 दिन पहले आप लोग को पता चला होगा कि इंस्टीट्यूट की ईमेल आईडी बन गया है सबका, ठीक है। भव्य, तुमको पता चला ये बात?
यस सर, मैंने उससे क्या बोलते अपना गिटहब का वो भी ले लिया।
अच्छा, ले लिया, ठीक है।
फ्री स्टूडेंट।
हाँ, ठीक है। तो उसमें क्या हुआ, उसके पहले 1-1.5 महीने 2 महीने पहले आपके सीनियर्स ने एक गूगल फॉर्म सर्कुलेट किया होगा, जिसमें मैंने पूछा था कि जिसकी ऑलरेडी बनी हुई है, इट वाज अ हरक्यूलियन टास्क, आई विल टेल यू बच्चा लोग, बिकॉज if you don't know, I'll tell you, I'm working alone right now, because my staff is not regularly coming. We are a very small team in computer center, and we need to do all those MS Teams and WebExes and Moodles and everything we are doing here. So as per the request of students, we did that. First of all, we need to delete all the old mail IDs, the students who have passed out. Then there was a dilemma that there are so many students who have already have their email IDs. Fine. So that's why the Google form was circulated, but sadly, few students, what they have done, they have given their MS Team ID that I have got email ID, and now they are having trouble. Fine. So just ask them to have patience. The IDs will be created. That's what I wanted to share. Thank you. Thank you. You can leave now.